Today, on how it's made. Stainless steel. Its reputation is untarnished. Football helmets. We reveal the tactical moves of the team at the factory. Resin figurines. A cast of characters. And laboratory glassware. Witness a real test tube birth. Stainless steel was invented in the early part of the 20th century, and the concept hasn't lost its luster. The key ingredient is chrome, which forms a protective oxide film on the surface. Originally, people were amazed that cutlery made from it didn't need to be polished. Called non-rusting steel, it was the talk of the dinner table. Stainless steel can be made to look shiny and new, even when they start with scrap. They recycle old stainless steel to make new, giving trashed sinks, pots, and a whole lot of other things a new lease on life. They feed tons of scrap steel into a roaring furnace, along with chrome and nickel alloys for added strength and rust-proofing. Enormous electrodes heat the mix to the melting point, and the show rivals a fireworks display. After several hours, the molten mix goes into a refining furnace. Pipes blast argon gas and oxygen up through it. This converts some impurities to gas and causes others to float to the surface so they can be removed. A technician regularly checks the temperature and takes samples to make sure the chemistry is right. They add a bit of scrap that bulks up the mix as it melts. The scrap also causes a chemical reaction that helps to fuel the refiner. The bubbling steel soup now flows out of the refining furnace, and rollers guide it as it's cast into a long mold. The result is a 70-meter-long ribbon of steel. Torches cut it into shorter chunks called slabs. A worker writes identification information on each one, using chalk that works on hot surfaces. They hoist the slabs over to another station to await further processing. After this break in production, they reheat the slabs to soften them up for more processing. A rusty scale has accumulated on the surface of the steel. They pressure wash it away without cooling the hot metal. Now the slab shoots back and forth through a machine with rollers. A constant spray cools the rollers as they stretch the steel longer and thinner. It's now over 600 meters long, the length of a couple of city blocks. They spray water on the stretched steel to cool it a little, but not too much, because it needs to be soft and flexible enough for coiling. This spool coils the strip tightly like a roll of toilet tissue. They then transfer the roll of steel to another station. Here the steel goes into a hot acid wash that removes scale that's built up since the last cleaning. Burners in this machine also heat the steel and then slowly cool it. This relieves stress in the metal, softening it for further processing. They now unwind the steel into a machine that rolls it thinner so that it's exactly what the customer ordered. Rolling the metal when it's cold also causes it to harden and makes the surface pores close so it shines. One last cleaning, and the stainless steel strips look spectacular. The chrome in the steel combines with oxygen in the atmosphere to form that oxide film that prevents it from rusting. Finally, rotating knives trim the edges and slit the steel to various widths, again to meet customer specifications. This job is now done, and it's a brilliant finish indeed. Football helmets cushion the cranium, helping players score touchdowns without losing IQ points. Helmets have been part of the sport for over a century. At first made of leather, they switched to padded plastic helmets in the 1950s, and they've turned out to be great shock absorbers for the skull. In a game of tackles and tumbles, a helmet is essential equipment. To make one, plastic pellets are suctioned into a machine that melts and molds them into a helmet. This fist-like device shapes the inside of the shell. It takes just seconds for the shell to harden. A robot collects it and transfers it to a conveyor. It's quite a lineup. The shells move into position for a trimming. They clip off an extra bit of plastic left over from the molding. Next, a robot drills up to 9 holes in the shell. The holes will be used to attach a liner, face guard, and various pieces of hardware. This robot works far more quickly than a human can, performing all the drilling in just 30 seconds. It's programmed to be extremely precise, doing a flawless job with computerized precision. Then the robot flexes back to receive the next shell. A worker collects the drilled shell and moves a new one into position for the robot. They rough up the outside of the helmet shell with an orbital sander. This preps it for priming and painting. The shells spin as they spray them with paint. It's a high-grade automotive brand. They get 3 coats because this paint job will have to be rugged enough to survive the game of football. The helmets cure in the open air for up to 18 hours. A chemical reaction occurs, causing the paint to harden to a glossy finish. Not every helmet is painted. Sometimes football teams prefer tinted plastic. It all depends on the look the team is going for. They attach labels, including cautionary information, trademark logos, and the date of production. This padding is made of vinyl and foam. They snap it in place in the crown of the helmet. The padding for the side and back is made of the same material. They reinforce the back with a plastic bumper. A helmet from each production run undergoes an impact test. The helmet has been fitted on a head-like form equipped with sensors. The technician calibrates the sensors using a computer. He presses a button, and the helmeted head falls. This mimics the effect of a player's head hitting the ground in a tackle. The computer then measures the force of the impact on the head form. Once the production run gets the okay, they attach the face guard. It's made of plastic-coated steel and has been custom produced at a different factory. There are dozens of face guard styles for the player to choose from. This helmet is now looking pretty fierce, but it's not ready for action yet. It needs chin strap and cup. This machine uses heat to transfer a foil logo onto the polyester chin straps. It also cuts them to the correct length. Once a chin cup has been sewn to the strap, they fasten the assembly loosely to the helmet. Later, it will be precisely fitted to the player. This helmet is now almost ready for kickoff. There's a final inspection, and then they wrap it up, complete with the manual and fitting instructions. It has taken less than a day to manufacture this football helmet. It's designed to hold up to thousands of impacts, because in the game of football, protection against head injury is a crowning achievement. Figurines come in many materials, from porcelain to plastic to resin. Not the kind that comes from trees, but a synthetic resin, a kind of plastic. It's affordable, lightweight, and easy to use, making it the material of choice for many artists and craftsmen. Each figurine in this collection is cast from a mold of the original sculpture, then hand-painted. This character is an actual 19th century federal marshal. Working from period photographs of her subject, the artist makes a sketch she'll use as a model. She needs plastic-based clay so it's easier to sculpt. She works in the facial features, referring to the photographs to create a true likeness. She usually starts with the figure's head, then adds it to the body. She works from more photographs to create his rifle. It's a delicate piece, so she sculpts it separately before setting it onto the figure. Bearing her signature, it's now ready for casting. First, the sculpture bakes for 30 minutes at 135 degrees Celsius to harden it. Then workers cover it with a thin layer of releasing agent so it won't stick to the production mold they'll now make. They place a wall around the piece, tightly seal the base to prevent leaks, then pour in a silicone rubber mix. In 2 days, the rubber hardens enough to hold the shape and the details of the sculpture, but is still flexible enough to enable workers to remove the original artwork without damaging anything. After removing the retaining wall, they use suction to gently pull the piece from the mold cavity, which retains the sculpture's shape down to every last detail. Now, figurine production can begin. Workers filled the mold cavity with a mixture of resin and flour made from ground pecan shells that colors the resin and makes it stronger. The mixture sets in less than an hour, and out comes the first of many figurines, a perfect replica of the original artwork. They sand the base to level it. Then they stamp it with the figurine's name, an ID number, and copyright information. Resin is an ideal material for casting because it captures all the details of the original artwork. It creates lightweight, durable reproductions that can be finished in a variety of ways. Here, the first artist coats the figurine's broad areas with acrylic paint. Working color by color, she uses various brushes depending on the areas to cover. She finishes up with the smaller details. Then she passes the figurine on to the next artist. She paints in the facial features and other fine details. She starts with the whites of the eyes, then views the figurine from all angles to make sure she doesn't overlook any tiny detail. Her fine brushwork on the facial features is what truly brings this figurine to life. Bass Reeves, U.S. Marshal, is just one figurine in this series that proudly honors the contribution of African Americans in shaping the history of the United States. Once Marshall Reeves passes inspection, workers wrap up production, so to speak, in protective bubble plastic. Each piece in the series comes with an authenticity certificate bearing the artist's signature, as well as the name and life story of the person the figurine portrays. Collecting this particular set of resin figurines appeals to more than the knick-knack lover. This is indeed affordable art for the history buff. Small-scale figures that pay a large-scale tribute to African-American pioneers. Their size, shape, and function run the gamut, ranging from beakers and test tubes to petri dishes and vials. Mixing, measuring, storing, or sampling is all in a day's work for a piece of laboratory glassware, built to withstand even the most potent of chemical concoctions. Many scientific breakthroughs are born here, inside laboratory glassware, the tubes scientists use to hold liquid samples for chemical experiments. They start off as thin glass tubing, stacked by size, weight, length, and diameter. Workers select the correct size for the culture tubes they're making and place them in a magazine. As it spins, it drops a tube into each slot on a cutting bed. Then comes the first cut by gas flame. When the heated tubing contacts the wet steel blade, the thermal shock results in a clean separation of the glass. The tubes get a second thermal shock treatment, which cuts them to length. Then it's onto the glazing bed. A glazing burner shoots out flames at a temperature of 650 degrees Celsius. The heat melts each tube at one end, forming a lip called a glass bead. Just 2 seconds of heat splits the tubes into two. The intense heat forces the glass bottom of each tube to close in on itself. The finishing fire smooths out the closure. Then they shoot a small amount of air into the opened end of the tube, which forms the round curvature on the bottom. Now the tubes head into an annealing oven side by side. They bake for about 15 minutes in 650 degrees Celsius heat. This strengthens the glass so it'll better resist cracking. The heat also sterilizes the tubes. Once the tubes cool, workers collect and pack them. Here they're making pipettes, long tubes that labs use to transfer fluids. A flame heats the glass to form an indentation, which determines the flow rate through the pipette. A wider flame then heats the glass, making it soft and malleable. Large rollers tug at the sides, drawing the soft glass to form the pipette's tip. Now for the other end of the pipette. They cut it to length using thermal shock, and again, a glazing burner forms a glass bead along the rim. A cutting wheel slices through the tip end, creating 2 tubes of identical length. This production line makes vials. These gizmos, called top turrets, feed large glass tubes into a machine. First, a punch-out burner heats the end of the tube to create an opening. Then a steel pin widens the hole on the upper part of the vial. A forming die squeezes the heated glass to sculpt the shoulder, while a steel plug rises from the bottom to open the vial even wider. Then a second forming die shapes the neck. Next, a parting burner splits the vial into 2. A bottom turret plucks the newly created one and draws out the soft glass to lengthen it. Fingers inside the turret prevent the glass from breaking. All that's left now is shaping the bottom of the vial. A burner forms a concave base in less than a second. The vials now slide down to what's called an afterformer machine. Here, suction cups lift and place each vial into metal grooves on a printer bed. It's a basic silkscreen printing process, with a squeegee pushing paint through the screen's holes onto the vial. Grippers now place the vials on a rack headed for the oven, where they'll bake for about 20 minutes. Finally, a robotic arm whisks the finished vials to packaging. From there, it's off to a blood bank, a hospital, or chemistry class. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.